Day 16 of 60. Today we are building a production-grade Nginx reverse proxy from scratch. Nginx sits between your users and your back-end services. How you configure that layer determines whether failures get absorbed or cascade through your entire stack. We will cover upstream blocks, SSL termination, rate limiting, caching, health checks, and performance tuning. Every config we write today, I have run in production. Upstream blocks and connection pooling. The upstream block defines your backend server pool. You list servers, set a balancing strategy like least_con, and configure failure detection with max_fails and fail_timeout. Here is what most people miss: Keepalive connections. By default, Nginx uses HTTP 1.0 to backends, opening a new TCP connection per proxied request. Under load, that burns thousands of file descriptors on handshakes. Add Keepalive 64, set proxy_HTTP_ version 1.1, and clear the connection header. Nginx now maintains 64 idle connections per worker and reuses them. I measured with SS and churn dropped 80%. The Keepalive_timeout and Keepalive_requests directives control idle connection lifetime and reuse count. Now SSL termination and security headers. Terminating TLS at Nginx means your backend services communicate over plain HTTP internally while clients get encrypted connections. You centralize certificate management in one place instead of deploying certs to every backend. Configure SSL_protocols to only allow TLS 1.2 and 1.3. Enable OCSP stapling so the client does not have to make a separate request to verify your certificate. Set up SSL_session_cache shared with 10 MB to avoid repeated TLS handshakes from the same clients. Then add your security headers. Strict transport security with max age of 2 years and include subdomains tells browsers to only use HTTPS. X-frame options deny prevents your pages from being embedded in iframes, blocking clickjacking attacks. Content security policy restricts which domains can serve scripts and styles. X content type options nosnif prevents browsers from guessing MIME types. Add the always flag to every add_header directive so headers appear even on error responses. I verify these with curl-I after every deployment. Rate limiting with limit_req. Nginx uses a leaky bucket algorithm. You define a zone with limit_req_zone, specifying the key, the shared memory size, and the rate. Use binary_remote_address as the key because it uses 4 bytes per IP address, so a 10 MB zone holds around 160,000 unique addresses. Create separate zones for different endpoints. I use 30 requests per second for general API traffic and 5 requests per minute for authentication endpoints. The burst parameter controls how many excess requests can queue up. With node delay, those burst requests pass through immediately instead of being spaced out. Without node delay, they get delayed to match the rate, which adds latency. Set limit_req_status 429 so rate-limited clients get the correct HTTP status code. For API endpoints, I add a custom error page that returns a JSON body with a retry_after field so clients know when to try again. Proxy caching is a resilience mechanism, not just performance. Configure proxy_cache_path with levels, keys_zone, max_size, and inactive timeout. The keys_zone holds metadata in shared memory while cached responses go to disk. The critical directive, proxy_cache_use_stale with error, timeout, updating, HTTP_500, HTTP_502, and HTTP_503. When your backend crashes, Nginx serves the last cached response instead of forwarding the error. That keeps your service partially available while you recover. Enable proxy_cache_lock so when 100 clients request the same uncached URL, only one request hits the backend. The rest wait for the cache to fill, preventing thundering herd during cold starts. Monitor through the Xcache status header: hit, miss, stale, expired, bypass. A spike in stale means backends are failing. Health checks and failover. Nginx open source uses passive health checks through the max_fails and fail_timeout directives on each upstream server. When a server returns errors or times out max_fails times within the fail_timeout window, Nginx marks it as unavailable and stops sending traffic to it. After fail_timeout expires, Nginx sends a test request to see if the server recovered. Mark one server as backup so it only receives traffic when all primary servers are down. Combine this with proxy_next_upstream to retry failed requests on a different backend. Set proxy_next_upstream_tries to cap retries so a genuinely bad request does not hit every server in the pool. For the API gateway use case, add location blocks that route different URL paths to different upstream groups. Each upstream group can have its own health check thresholds, Keepalive settings, and timeout values. Performance tuning to finish. Set worker_processes auto to match CPU cores. Each worker handles connections independently, so 4 cores gives 4 workers. Set worker_connections to 4096 for 16,384 total concurrent connections on a 4-core box. Bump worker_limit_no file to 65535 so the OS does not cap file descriptors below your connection limit. Enable epoll for Linux, send file for static content, TCP_nopush and TCP_nodelay for packet delivery. Enable gzip for text and JSON with a minimum length of 256 bytes. Buffer access logs with 64K buffer and 5-second flush to reduce disk writes. Validate under load with work at 2000 concurrent connections. If you see drops, check worker_limit_no file first. Day 16 done. See you day 17.